Hello everyone! In this video I am going to show you basics of multithreading in C++. As an example project using multithreading, I will use a small program that counts number of consecutive zeros in binary representation of large set of real numbers. More precisely, the program prints binary representation of numbers that have the highest count of consecutive zeros. Application is written in Visual Studio 19 and is a C++ console application. The set of numbers is created by multiplying elements of several vectors, each with everyone. Type of vector element is CPP bin float from Boost multi-precision library. Here FF is defined as type of number CPP bin float with 100 significant binary digits. As you can see, there is a main vector mulc2 which contains vectors with CPP bin floats. For example, first vector contains pi raised to several integer powers, and the second vector contains pi to the fractional powers. Each vector has around 20 elements and there are 5 vectors total, so total count of numbers is 20 to power 5, so around few millions. There are four threads. Each thread processes 1/4 of all numbers. The numbers are divided by third vector. Here, threads names are T1 to T4, and each thread is joined, so the main thread is blocked until these 4 threads finish. First parameter in thread constructor is name of the function to execute. You can see is func4. The rest of arguments are func4 function parameters. Let's see func4 definition. Top array holds up to 60 numbers with highest count of consecutive zeros. There are 2 time points, start and end, used to calculate time for every iteration of main loop. TID is ID of current execution thread. To print ID of thread with duration time of main loop iteration, we use logguard that owns a mutex mute for the duration of scoped block. So when the block ends, the mutex is released. We make sure that only one thread is executing std cout at the same time. Now I will run the program and we will see the synchronized output. So we have thread ID followed by a colon and then duration of the loop iteration in seconds, and then 2 loop indexes. We see that we have all nicely printed one below another. let me run this program once again without log guard. I will simply comment it out. Now we can see that we have disorder. This happens because C output is not guarded by a log. It's because multiple threads executing same line at the same time. Let's look further. Inside for loops is calculating CPP bin float number val. Then its 0 and 1 bits are written to CPP int temp CPP int by var backend bits. Then the program calculates highest number of consecutive zeros in that number. And further, it's written to top array if it's more than 10, or when top array is full if it's greater than top array minimum. Next, we are waiting for each thread to execute for loops with condition variable cval. First we obtain mutex mute2 by logguard lg, and then set bits in thread sentinel corresponding to thread number. Thread number is value from 1 to 4, so after each thread call this line, thread sentinel will become 15 or f in hexadecimal. We are waiting for this to happen in cv.wait with condition checking if thread sentinel is set for all threads. cv.wait condition in all threads is checked after cv notify all call. Let's comment this fragment out and see the console output. Here we see that one of the threads started printing numbers before execution of main loop in other thread, so we see console output jumbled. The rest of the func4 code is writing indexes of vector mulc2, then writing number of consecutive zeros, and finally binary representation of that number. This fragment is also guarded by obtaining a log of mutex mute3. Without this log, we would have a mishmash. Let's run a program one more time. We see that we have indexes of multitude vector and number of consecutive zeros, and then binary digits of a number. It's all nicely printed out one after another. That's all. Thank you for watching.